Sets and Venn diagrams is the topic for today's class. We're going to start with the basics of sets and Venn diagrams. This topic can come in either any of the two papers. Either it can come with calculator or without calculator. So you can expect in any one of the two papers. Usually, for this topic, we don't expect much lengthy questions. Usually, what the weightage we have seen so far is it goes from 2 to maximum 6 marks. It's an easy topic, must to come. So you can expect in any one of the two papers. Or sets and Venn diagrams. Sets and Venn diagrams. This topic is also called as set notations. So set notations, and to understand the notations, we first need to understand all the language in which we would be dealing with the sets question. So for language, we need to know the sets symbols first. So we'll go through all the symbols one by one and how do they work and what do they mean. First, we'll go through all the symbols and then we'll go for the type of questions. Okay, starting with the definition of sets. Um, Sets, it's defined as collection of objects. Now, for collection of objects, you have to be clear about that the collection of objects should be having some similarity or characteristics. How do we represent set? We always represent set by these curly brackets. Like for example, if I have to say we have a set A or set P, which is the set of Toyota cars. So we can write the set P as we have the cars of Toyota as Corolla, which Paso and so on. So this is how we represent sets. So set is collection of objects, and collection of objects would be having some similarity or some characteristic in common. All right, now the other symbols to be followed, for all the other symbols, we would be considering these three sets throughout as a reference, as an example. So we have already defined the three sets. We have a set A having the elements as 1, 2. When I use the word element means object or items inside the set. Okay, so we have three sets here. Set A is having the elements 1, 2, B is having elements as 2, 3, 9, and C is 3, 9. The first symbol to go for is this symbol called as intersection, which is represented by this kind of N. It's not exactly N, it looks similar to N. Now, what is the speciality for the symbol intersection or N? It looks for the common elements between the two sets. So if, for example, I have picked up two sets here, if this is written as A intersection B, so A intersection B, I have to look for the elements which are common in A and B. How this works, this is going to be A intersection B means you first write down the elements of set A, which is 1, 2, intersection in between, and then you write the elements of B, which is 2, 3, 9. So intersection always means you have to pick the common elements between the sets. And for these two sets, you can see there's only one single element common, which is 2. So it would result in 2. Next, we have the symbol as union, which is kind of you, not exactly you, but looks similar to you. What union does is it adds the elements. Intersection picks up the common elements, union adds the elements or combine the elements. So A union B, if it is to be found, A union B means you write the set A first, which is 1, 2, union in between, and then you write the elements of set B, which is 2, 3, 9. So union means add or you combine the elements of the two sets. So when we combine the elements of the two sets, you will get the combination as 1, 2, 3, 9. Please note one thing, 2 was common between the two sets. You don't need to write the elements twice. 2 is there in both the sets, so you'll be writing 2 once only. You don't need to write 2 twice. Next symbol, subset. Subset is defined as that one set is a part of another set. One set being part of another set means the example you can see here is I've written down this as set 1 is a subset of A. Subset of A means 1 is a part of set A. Next example, 3 comma 2 is a subset of B. Yes, we can see 2 and 3 are there in set B also. So you can write this as B, 3 comma 2 is a subset of B. Next example, this is C is a subset of B. So C is a subset of B, and you can clearly see here C is having the elements as 3, 9 is a subset of B, which is having the elements of 2, 3, 9. So all the elements, all the elements of set B, of set C are part of set B. I'm highlighting the word all the elements. It has to be all the elements and it has to be the part of the other set. On the contrary, we have the next symbol as not a subset. Not a subset means it's the other way around. That means one set is not a subset of another set. For representing not a subset, you have this crossed line applied on the subset symbol, not a subset. So the example I've given is 1 comma 3 is not a subset of A. And yes, you can see that if I write 1 comma 3 and on the other side I'm writing set A is having the elements as 1 and 2. So you can clearly see that it's not a subset of 1 and 2 because all the elements should be there uh, in the second set. For example, I can say Karachi, it's a subset of Sindh, and Sindh is a subset of Pakistan. But I cannot say Sindh is a subset of Karachi. I can say Sindh is a subset of Pakistan, but I cannot say that Sindh is a subset of Karachi because Sindh is a bigger set, Karachi is a smaller set. So this is how you represent not a subset. Okay, next symbol we have null set or empty set. Null set or empty set means the set is having no elements inside. So there are two ways of writing it. Either we write this as empty set with no elements inside, or we write this as the null set. These are the two ways of writing it. Acha, some students they do this mistake of writing this as a null set, which is wrong because this means that you are saying that zero is an element of set. This approach is wrong, whereas for empty set or null set, this and this approach, these two approaches are correct. So make sure you're not making this mistake for the null set. In case of this example, A intersection C is a null set. Why? If I have to find A intersection C, A is having the elements as 1, 2, intersection C is having the elements as 3, 9. We have to look for the common elements for the two sets. And we don't see any elements common for the two sets A and C. So that is why its intersection would be a null set. So either you keep the set empty or you write this null set symbol. They both mean the same thing. Next symbol is called as is a member or is an element. So you also call this as is an element. So 2 is a member. For this thing, you read this as this thing, you read this as 2 is a member. If it is written as 2 belongs to A. So either you read this as 2 is an element of A, or you may read this as 2 is a member of A. And there's one more way of reading this. You can also read this as 2 belongs to A. These are the different ways of reading this symbol belongs to or a member of. Next symbol, not a member. Not a member means the belongs to symbol would have a cross line applied on it. Example 4 doesn't belongs to A. And yes, you can see that 4, if you look for the set A is 1 and 2. And you can see that 4 is not a member of set A. You will simply cross it. Next symbol, N of A. N of A means wherever this letter N is used, this letter N represents the count of the elements. It's read as number of N of A means it means number of elements in set A. So be clear about two things. When it says A means you have to list down the elements of A. And when it says N of A means you have to write down the count of elements of A. So if you may look at the set A is having the elements as 1 and 2. When we say N of A means you have to write the count only. So these are only two elements here, so you'll write the count as 2 only. If you look for N of A union B, N of A union B. So for N of A union B, you first need to find A union B. A union B, you combine the elements of A and B. So A and B have already found this as 1, 2, 3, 9. A union B is 1, 2, 3, 9. And when it says N of A union B, N of A union B means you simply need to write the count, the number of elements in the set A union B. So these are only four elements, so you write the count as 4. Please don't write this as 4 inside the set. This is wrong because what this means is you're trying to say that 4 is an element of the set, whereas 4 has to be the count only. So this is right. You only write the count as a number only. Don't write the number inside the bracket. The next symbol is the symbol of universal set. Universal set means the bigger picture, the biggest picture. The biggest picture means we can say that the Cambridge board is the universal set for the Cambridge examinations. So you would be having different examination centers, like examination centers in Pakistan, in India, in Saudi, in Dubai. So they have different uh, examination centers, so different sets of examination centers in different countries, whereas the board itself, the Cambridge board, is the universal set, which is the all-in-all authority for conducting the exams. So universal set means the biggest picture. In case of this example, I have defined the universal set as the elements from 1 till 10. So always remember universal set is the biggest set. Just a minute. Okay, the next and the last symbol is the complement of a set. Complement means complement means you have to remove the elements of that particular set from the universal set. If it says complement of A complement means you'd be removing the elements of set A from the universal. Now, universal, we know that it's having the elements as universal in this case is having the elements as 1 till 10. And A is having the elements as 1 and 2. So if you have to find A complement means you'd remove 1 and 2 from the universal. Universal goes from 1 till 10. So if you may remove 1 and 2 from the universal, you'll get the result as 3, 4, 5, 6, and it will go until 10. If it says, for example, B complement, if you have to find B complement, we know the elements of B. Elements of B are 2, 3, and 9. Elements of B are 2, 3, and 9. So B complement, it would be removal of the elements 2, 3, 9 from the universal. So if you may remove it, you'll get the result as 1, 4, 5, 6, 7, 8, 10. So this was all about the symbols to be used in sets. Okay, and last thing, representation of sets. When we say representation of sets, we have two different forms of sets. The first form is called as um, set builder form, and the second one is the tabular form. So set builder form is basically a descriptive form of number where you describe the elements or explain the characteristics of elements inside the set. For example, you have the set A as x x belongs to natural numbers and x is between 1 to 10. Okay, how do you read this? You read this as the first x means for all x. So this means this bracket means set of, and this x means all x. Now you're defining the x. It means that this is about a variable x or the set of values of x. And what is x? This colon sign is read as such that. This means x belongs to natural numbers. So they are defining the elements of x. X belongs to natural numbers. And in the end, they have given us the range of x that goes from 1 till 10. So this is what we mean by set builder form. Tabular form is simply the listing of the elements. Simply the listing of the elements. If for the same set, if I have to write the tabular form is related tabular form, its related tabular form would be 1, 2, 3, and it goes until 9. I will not be including a 10 here because if you observe here, 10 is exclusive, 10 is not inclusive. And for natural numbers, you have to keep the whole numbers only. You don't write decimals. So this is the main difference between set builder form and tabular form. So in any given question, if a set builder form is given, always write its related tabular form first. Okay, a few examples. It is given that x is an integer, so this is a tabular form given. So x, set of x, so how do you read this? You read this as set of x such that x, now what is x? X is an integer. This is how you read the the set builder form. So it's better to list down the elements. So the universal set here, it goes from 1 till 15, all integers. Next we have set P. So set of x such that x is a prime number. Again, you list down the elements of P. The prime numbers, you have to consider all the prime numbers within this range of the universal set. So within the range of universal set 1 till 14, the prime numbers are 2, 3, 5, 7, 11, 13. So these are all the prime numbers. Factor of 12. So factor of 12, you have to consider all the numbers which would result in 12, which when multiplied would result in 12. So the factors for 12 are 1, 2, 3, 4, 6, and the number 12 itself. So all these numbers would be resulting in 12 when multiplied with some other factor or number. After writing down the sets, now the question is about list the elements. So that is one type of question in sets, listing the elements. So listing the elements means you have to write the set including all those elements. So P intersection Q first for the first part, P intersection Q. So P intersection Q means you first write down the elements of P. Elements of P are 2, 3, 5, 7, 11, 13. Intersection, the elements of Q. Q we have 1, 2, 3, 4, 6, 12. The intersection means you have to look for the common elements. And for the two sets, the common elements are 2. We have 3. We have, that's it, 2 and 3 only. So P intersection Q, the result is 2 and 3. Second part, we have to find P union Q. As discussed earlier, for union, we combine the elements. For set P, we have the elements as 2, 3, 5, 7, 11, and 13. Union. For Q, we have the set as 1, 2, 3, 4, 6, and 12. So when we combine these sets, it would result in 1, 2, 3, 4, 5, 6, 7, 11, 12, and 13. Part 3, P intersection Q complement. Now, P intersection Q complement. So, P, we know that it's the elements as 2, 3, 5, 7, 11, and 13. Intersection Q complement. Now, for Q complement, we already have the set Q with us. So, it's Q complement. If we have to find the Q complement means all the elements other than Q. So we have to remove Q from the universal. If we remove Q from the universal, we'll have the elements as 5, 7, 8, 9, 10, 11, not 12, 13, and 14. This is all Q complement. So Q complement, this is 5, 7, 8, 9, 10, 11, 13, and 14. Finally, I have to pick the common elements here. Common elements for P intersection Q complement. The common ones are 5, 7, and 11, 13. So 5, 7, 11, 13. 5, 7, 11, and 13. Next part, P complement union Q. So P complement union Q means I have to first find P complement. So we already have a P with us. P complement would be the set excluding Q, excluding P. So excluding P, we're gonna have this as 1, 4, 6, 8, 9, 10, 11 is there, 12, and 14. So this is all P complement. The P complement, if you may write, 1, 4, 6, 8, 9, 10, 12, and 14. Union Q, it's 1, 2, 3, 4, 6, 12. So their union, you combine the elements. So combining the elements, you'll get 1, 2, 3, 4, not 5, 6, not 7, 8, 9, 10, not 11, 12, and 14. Part 5. Now this time this is P complement intersection Q complement. So P complement and intersection Q complement, we have already have these sets P complement and Q complement. So directly write these sets. P complement is 1, 4, 6, 8, 9, 10, 12, 14. Intersection Q complement, it's 5, 7, 8, 9, 10, 11, 13, and 14. Now you have to pick the common between the two sets. So the common of the two sets are, uh, we have 8 common, then we have 9 and 10 common, and we have 14 common. So 8, 9, 8, 9, 10, 14. Part 6, it says n of p intersection q. Now this is where students sometimes make mistake. So n of p intersection q. We have already found the value of p intersection q. You see p intersection q is already found, which is 2 comma 3. Now this time it says n of p intersection q. The n of p intersection q means now you don't need to write the elements here. You need to write the count of the elements. So P intersection Q has only 2 elements there. So n of P intersection Q, the result would be only 2. Don't write this in set 2. If you write this as this thing, so it would be wrong. So you only need to write this as 2 only. Part 7. This is now n of P complement intersection Q complement. So here again we have already got the value of P complement intersection Q complement, which is this set 8, 9, 10, and 14. So here you need to write their count only. So n of P complement intersection Q complement, the count is 4. Part 8. Now we have to find n of P union Q whole complement. N of P union Q whole complement. Now this one is a bit tricky. So P union Q whole complement, and you have to find the count of it. It's n of P union Q whole complement. So what you need to do is first you have to find P union Q, what P union Q is. You have already found the value of P union Q in part 2. So P union Q, it's 1, 2, 3, 4, 5, and so on. And if its complement is to be found, so complement means all the elements other than P union Q. So all the elements other than P union Q would be 1, 2, 3, 4, 5, 6, 7 are already there. So the complement would be having 8, 9, 10, 11, 12, and 13 are there. So 14. Yeah. These are the 4 elements in the set P union Q whole complement. And finally, n of P union Q whole complement, it will be the count, which is only 4.